Hello guys, this is Dr. Manjunath Chennapgod from Anveshana Academy, Bangalore, India. Dear students, welcome to my YouTube channel. Dear students, in the previous class we discussed about what is thermodynamic process, what are the examples for thermodynamic process, and what are the different types of processes are there based upon macroscopic properties. In detail we have discussed. Dear students, let's come today we will move towards next topic, that is thermodynamic process. Okay, dear students, it is a continuation of previous class. Okay, thermodynamic process, what we are going to discuss in this thermodynamic process today, we will see. Okay, so now dear students, we discussed thermodynamic process, okay, in detail in previous class. Dear students, here you can see here now, based upon the condition of the system or parameters of the system, we are going to have different types of processes. Based upon the parameters of the system, we can have different types of processes that you can see here now. One is reversible process, irreversible process. What is reversible process, dear students? You can see here now, a process that can be reversed without leaving traces on surrounding, that is known to be reversible process. What is irreversible process? A process that can be reversed due to energy dissipation, that is known to be irreversible process. Okay, now third process is flow process. What is flow process? A process involving mass transfer across system boundaries, that is known to be flow process. What is non-flow process? A process with fixed mass within the system boundary, that is known to be non-flow process. Then next is cyclic process, where what is cyclic process? A process where the system returns to its initial state, that is known to be cyclic process. Then last one is non-cyclic process. These are different types of processes we are having in our thermodynamic system. Okay, what is these all different types of processes that we will discuss in detail today by taking some live examples as well as technical examples, dear students. Now you can see here now, I listed this, right? These are all processes. Okay, I will explain one by one, reversible, irreversible, I will explain one by one. But here you can see here now whether these kind of processes are really applicable in our day-to-day life. Is there any application of these kind of processes? Yes, there are n number of applications are there. Okay, what are those? You can see now. If you take reversible process, we can have equilibrium or idealized. What is the characteristics of this reversible process? We can see. I will take some examples and I will tell you what is reversible process. Reversible process is an equilibrium process and it is an idealized system. Sorry, idealized process. That means we can imagine, but practically it is not possible. This is what reversible process. Then second one, irreversible process, dear students. What is irreversible process? Here entropy will increase, whereas it is non-equilibrium. It is not a equilibrium process. Okay, fine. Next, flow process is there. What is that flow process? Open system we can take to explain this flow process. What will happen here now? In this flow process, mass transfer will takes place. Okay. Then non-flow process. What is non-flow process, dear students? You can take a closed system. In non-flow process, the name itself indicates there is no movement or there is no flow of mass. That is nothing but what? Non-flow process. During a process, there is no mass transfer across the system boundary. That is known to be non-flow process, dear students. Okay. The next, cyclic process, where cyclic process examples what we can give: heat engines, refrigerator. Okay. Next, non-cyclic processes we can give example. We can tell that it is a state change process and it is a permanent alteration process, dear students. Okay, these are what different types of processes and important characteristics and some examples we have seen. Dear students, let's come. We will study in detail about reversible process, irreversible process, flow process, non-flow process, cyclic process, and non-cyclic process. Okay, dear students, I will take one live examples and I will try to explain you what all these type of processes that you can see here now. Now, I will take a bus as a system. Okay, it is moving from one point to another point. So, what is reversible process here, dear students? If the bus or a system, I will call it as a system. If the system is leaving from point 1 and it is reaching point 2, again it will come from point 2 to point 1. If it is coming and going back to its original position, but it will not leave any kind of traces to the surrounding. That means what? There is no heat dissipation, there is no mass transfer. If the process happen in that fashion, that we can call it as a reversible process. The reversible process is a process in which the system can return to its original position, but there is no any traces on the surroundings. That is known to be irreversible. Okay, sorry, irreversible process. What is irreversible process? The system will leave from point 1 and it will reach point 2. It will go back to its original position. It will go back to its original position, but some amount of heat or energy is going to transfer from system to the surrounding, or some amount of mass is going to transfer from system to the surrounding. That you can take, dear students, exhaust emission, or you can call it as a hot gases. The hot gases is coming from bus to the surrounding. That means what? System to the surrounding. If it is coming, some amount of heat and mass they are getting transferred. If the mass and energy getting transferred into the surrounding, that means what? There are some traces on the environment or surrounding by the system. That we can call it as a irreversible process, dear students. And whatever the examples we can see in our day-to-day activities, right? These all are irreversible process. But reversible process we can imagine, okay, but we can idealize it, but not practical. Okay, fine. Flow processes now. What is flow processes, dear students? As I told, assume that whenever you are supplying air, right, and the combustion will happen, the emission is coming out. That means what? Certain amount of mass of gas is coming out of the system and it is entering to the surrounding. That means what? During a process, if the mass is crossing the system boundary, then that process we can call it as a flow process. A process in which the mass is going to transfer from system to the surrounding. That is known to be flow processes. Suppose if there is, assume that from the system, if there is no any mass transfer, then the type of process we can call it as a non-flow process. Then cyclic process. What is cyclic process, dear students? A process where the process in which the system is going to return its original position, and the original and final positions are identical. Okay, the properties of the system, initial and final, are identical. That is known to be cyclic. If the properties, if it is not at all returning back to its original position, that is known to be non-cyclic process, dear students. That we can see now. This one example, with help of this example, we can understand what is these all type of processes now. Now, what I will do in detail, I will explain you what is reversible and irreversible and other properties. Now, in today's class, we are going to discuss about what is reversible process and irreversible process. Okay, now dear students, you can see one example you can see here now. These all kind of process that you can see here. Okay, from the compressor, compressed air, little bit it is hot air is coming and it is entering into the tire. That means what? The mass is getting transferred from compressor to the tire. That means mass transfer is taking place. That is nothing but what? Flow processes. The reversible process means what? If the system is getting returned to its original position, if there is no any traces on the surrounding, that is known to be reversible process. What is irreversible process? The mass is getting transferred, our system is doing work, but the heat is getting transferred to the surrounding. Either it may be in terms of heat dissipation, may cause due to friction or something else, but that means some amount of heat is getting dissipated to surrounding. That means there are some traces on the surrounding. That is known to be irreversible process, dear students. Okay, now you can see here now what is reversible now. Reversible, that you can see here now. Reversibility, the ability of a system return to its original state without net change. That means what? As I told, it will come the system, we can take, dear students, that system will leave point 1 and it will reach point 2. Then again it will go back to original position, that means point 1. During this process, that system will not leave any kind of traces. That means it will not leave heat to the surrounding, or it will not leave hot gases to the surrounding. If such kind of process happens, that process we can call it as a reversible process. But the reversible process is an equilibrium condition. It will happen in equilibrium. How it is then? It will come, it will leave from point 1 and it will reach intermediate point. You can call it as A. Again, the system will be equilibrium at point 1. Again, system will be equilibrium at point A. Again, system will be equilibrium at point B. And that means this reversible process is going to have equilibrium condition at each states. That is known to be reversible process. But dear students, this process we can only idealized but not practically. So it is an idealized concept but not perfectly achieved in reality. That means what? It is not practical. Okay, examples you can take. Instance illustrating reversible process. You can take, I will tell examples. Okay, this is what? Reversible process. Okay, reversible process, ability to return to its original position and it will not leave any traces on the surrounding, and it is going to attain equilibrium condition at all states, and it is a ideal one but it is not practical. Okay, now you can see here, what are the examples now, dear students? We can see here a number of examples. Frictionless relative motion. Dear students, we can see here, when it comes to piston and cylinder arrangement, right, you can see when it is piston is oscillating, right, there is a friction. If there is a friction, some amount of heat is going to generate. That heat is going to transfer from system to the surrounding. If the heat is transferred to the surrounding, that means what? There is some heat traces or mass. That means what? Hot. Assume that only heat here now. Heat is getting transferred means what? Heat traces on the surrounding. If it's so, we can call it as a irreversible. But what we can assume here now? You can assume that the piston is oscillating but the friction is zero. There is no friction. But dear students, without friction the piston will not oscillate. But we can only imagine. It's an ideal process. Okay, there is no friction in the relative motion. Okay, what are the examples we can consider here now? One is piston and cylinder arrangement, but there is no any kind of friction, dear students. One example. Now we can take spring example. You can take in your suspension car, or you can take a bike. That spring, it will compress when load is acted on the spring, and it is going to expand once the load is released. That means what? It is going to return its original position. Okay, but dear students, when it compress and expansion, right, it's little bit friction will be there. Because of that friction, heat may transfer to the surrounding. But what we can do? We can assume there is no friction at all. If it's so, that is an example of what? Irreversible process. Frictionless adiabatic expansion. Dear students, when it is either it may be expansion or compression, some amount of heat will getting transferred from cylinder to the surrounding. But if you made it as a perfect insulation, then there is no kind of heat transfer. If there is no any kind of heat transfer from system to the surrounding during expansion, that we can call it as one of the best example for what? Reversible process. But dear students, we can't restrict 100% transfer of heat from system to the surrounding. There may be small amount of heat may getting transferred. So therefore only what we are telling, it's an idealized process. You can take an electrolysis process, dear students. Whatever the energy we are using, right, the same energy we are going to get according to this reversible process. But practically it is not possible. This is about reversible process. Okay. Now I will move towards next one, irreversible process. What is irreversible process, dear students? Initially, you can see here now. Initially, it will start from at a point 1. Okay, then it will start at a point 1, and when it will start from point 1 to point 2 or point 2 to point 2, but there is some amount of heat as well as some amount of mass is going to transfer from system to the surrounding. That is known to be irreversible process. Okay, then next, whenever it will move, right, it will take, you can take any point or states. Okay, it will not attain equilibrium condition. But when it comes to reversible process, it is going to attain equilibrium condition at each point. But when it comes to irreversible process, it's a non-equilibrium process. One thing, during process, some amount of, as I told, heat as well as mass is getting transfer. Hence, energy transfer will or energy dissipation will takes place, dear students. Then what happens? It will reach from point 1 to final state. Again, it will come back to 2 to 1. Again, it is going to attain non-equilibrium. Then some amount of heat is getting transferred to the surrounding. That means what? It is going to leave some traces on the surrounding. If it's so, that process we can call it an irreversible process, dear students. Okay, fine. What are the example for irreversible process that we can take? Energy dissipation. You can take it bus or a system itself. During movement, right? There may be friction between tire and the road. Because of that friction between tire and the road, the heat energy may get transferred from system to the surrounding. That means what? That system is going to leave some traces on the surrounding. That is one example for a irreversible process. Then what will happen now? It is going to increase the entropy. That means what? Thermal energy is going to generate more, but sometimes what will happen? That thermal energy we are unable to utilize to do the work. Hence, entropy will increase. As I told, dear students, it's a non-equilibrium state. Whenever it is going to reach, right, all the states we can take, it is a non-equilibrium state. And whatever the examples we can take in our day-to-day life, right, all are irreversible process. What are the examples that we can see here now, dear students? Okay, so combustion. We can take IC engine itself. When it is going to combust, right, when the air fuel is going to combust, right, then what happens? Combustion will take place and exhaust gas will come out and it will enter into the surrounding. That means what? It's an irreversible process. How it is that heat is getting transferred from system to the surrounding, one thing, as well as the mass is getting transferred to the surrounding. That means what? Some effect or some traces we are going to leave on the surrounding. If it's so, during combustion, if it's so, that we can call it as a irreversible process. Then plastic deformation. That's also one kind of, that's also one of the example for irreversible process. Throttling process. Suddenly what we are going to do? We are going to decrease the pressure of the fluid when it is moving in the pipe. If suddenly is decreased, right, we can't get back the same pressure with pressure in the throttling. That's also what? Irreversible process. That means what? Some amount of pressure energy is going to drop. One thing. Now, heat transfer. When as I told, when it is combustion takes place, right, heat is generated. That heat is going to, some amount of heat is going to transfer to the surrounding. But that heat loss, if it happens, that means what? There is some traces on the surrounding. If some traces are there on the surrounding, then that type of process we can call it as a irreversible process, dear students. Okay, I hope you understood what is reversible process and irreversible process. Okay, dear students, if you have any doubt, you can comment and you can ask. Please do like and comment and share. At the last, you subscribe my channel to get more and more educational videos. Thank you.